Hi, welcome to Project 1907D's Design Day video presentation. We are the automatic hypodermic tube bending machine sponsored by AliCAD Scientific. I am Team Lead Gabriel Alexander Garcia. For this scope, we were tasked to create a prototype that would bend hypodermic tubing into what we like to call the bottom side shape of the clothing hanger. The reason for this shape is AliCAD uses that shape within the Coriolis mass flow emitters that they create at their building. We are also tasked to provide all documentation that helps us get to our end result. For our system requirements, we are asked to bend 20 to 30 gauge tubing with a 2 1,000ths to 6 1,000ths wall thickness. All bends have a 1 degree tolerance allowed. Produce our shape within under 5 minutes. Cut all pieces of tubing into 8-inch pieces. Environmentally, power the machine by a US wall socket. Fit on a normal sized 4 to 5 inch table. Interface size, we used 2 phase stepper motors to provide the bending ability and feeding ability of the tubing. We also used Arduino Uno and Raspberry Pis for the control of the machine. On the safety measures, we had a safety switch for on and off and kill switch, warning labels for the machine, and we were asked to make this a user-friendly design.
Here we have some diagrams that show 3 different bend methods. Typically, rotary draw bending is the industry standard, but we decided to use compression bending since it requires less moving parts and it would greatly simplify our system. Here we have a model of our assembly. This was used to fabricate a lot of the 3D printed parts and also make some of the wooden parts. This was also used as reference to help us build our assembly. This is the initial bend die design. We use this to test our system to see how well it performs with simple bend die. This is the second design, which was an improvement of the first design. This was curved to make sure that there isn't any crimping at the bend location. With this bend die, we had some problems when trying to 3D print it because the hole that is used to guide the tube was too small for a 3D printer to recreate, so the hole was completely covered when it was printed. This is the final design of our bend die. We decided to split the part in half to make sure that the feed hole is printed correctly. This design also has 2 different bend radii to make 2 size bends, which is needed for our tube shape.
The main use case that we wanted to solve follows this chart. The engineer will find the optimal tube shape calculations, input the shape through the GUI, hit reprogram and start on the GUI, and then the bending process will start. We wanted the solution to this use case to be user-friendly with minimal instructions necessary. In order to achieve this, the team decided to implement this hardware-software stack. We wanted to be able to run this software on any OS. On top of that is a Python-based application using Tkinter for the graphical user interface. From there, based on user input, the Arduino driver script is pragmatically generated and ready to go to be uploaded onto the Arduino Uno and start bending. Taking a close look at the wiring of the machine, we decided on using 2 NEMA 17 2-phase stepper motors for the feeding and Z-axis rotations. From there, we have a NEMA 23 utilized for the bending process. All of these are being driven by the DRV 8825 motor driver. For the bending pin itself, a stepper motor is being used, and the power for the machine comes from a 12-volt supply and the 5 volts from the Arduino Uno board itself. The software for our project had a number of dependencies. However, these were all packaged up into an executable, so a user should be able to just click and be on their way. The software flow that the team was going for has 2 paths, the first being the user hits the Draw To button. This triggers the display config, redraw, and display current shape functions. The code takes the user-defined dimensions and redraws the desired tube onto the screen. The second path occurs when the user hits the Generate Script button. This sends a request to the team's GitHub and pulls down the basic Arduino script.ini file. The generate function then parses the basic file and inputs the user dimensions from the GUI and outputs the Arduino script.ini file with the desired dimensions populated, an example of which can be seen here.
From the testing, we are confirmed that our prototype was able to feed and bend the tube. In the meantime, we also provide advanced ANSYS simulation results on how tube reacted during the bending process. The reason why we provide the ANSYS result is we would like a proper force to apply onto the tube to avoid plastic deformation. In conclusion, our team managed to successfully build the prototype. We were also able to write the code that moves system components in the correct manner. We designed several bend-dies to improve the bending performance of our system. Overall, our team overcome the current situation and finished to build the machine. It's such a unique experience as a design engineer. We gain lots of useful skills throughout this project.
Please take a few moments to review our poster. Everything described in the poster has been covered throughout this film. We would like to take this time to thank the Craig M. Berg Foundation for funding Design Day, as well as our team sponsor, Alley Cat, and our team mentor, Doug May.